You receive 10 comments on something you worked hard on. 9 are positive. 1 is critical. Hours later, your mind is still replaying the critical one. The positive feedback fades into the background, but that single negative signal stays with you, and it may even shape how you feel about the entire situation. Why does the brain behave this way? Why does one negative signal often outweigh many positive ones? To understand this, we need to look at how the human brain prioritizes information, because the brain does not treat every signal equally. Some signals are given special priority, and negative signals sit at the very top of that list. But to see why, we need to go back thousands of years. For most of human history, the environment was unpredictable and often dangerous. Missing a positive opportunity rarely threatened survival, but missing a threat could be catastrophic. A hidden predator, a hostile group, a dangerous terrain. In these environments, the brain evolved a powerful survival rule. When in doubt, pay attention to potential danger first. And this rule became deeply embedded in the brain's architecture. At the center of this system is a small but powerful structure called the amygdala. The amygdala acts as part of the brain's rapid threat evaluation network. It constantly analyzes incoming sensory information for possible risk. Facial expressions, tone of voice, unexpected sounds, subtle changes in the environment. The amygdala processes these signals extremely quickly. In fact, it can begin responding to potential danger before the thinking part of the brain has fully processed the situation. But here's where it gets interesting. The brain does not simply detect threats, it prioritizes them. Research in neuroscience consistently shows that negative information activates the amygdala more rapidly and more strongly than positive information. This phenomenon is known as the brain's negativity bias. It means the brain is wired to notice potential problems faster than positive events, and this bias shapes how we interpret everyday experiences. Imagine walking into a room where several people greet you warmly, but one person gives a neutral or slightly cold reaction. Your brain may immediately focus on that single negative signal, even if the majority of the interaction was positive. And this leads to an unexpected effect. The brain begins analyzing that signal in greater detail. Was something wrong? Did I say something strange? Are they upset with me? The brain starts running internal simulations, trying to interpret the possible threat. But the brain doesn't stop there. Once a negative signal is detected, the brain also strengthens the memory associated with it. Emotional brain systems interact with memory centers, such as the hippocampus, making emotionally significant events easier to remember. This is why embarrassing moments can stay in memory for years. The brain treats them as important lessons for future survival. In ancient environments, remembering mistakes helped prevent repeating dangerous situations. But in modern environments, the system sometimes becomes overly sensitive. Instead of reacting to physical danger, the brain often responds to social signals. A critical comment, an uncertain message, a moment of awkward silence. The brain interprets these as possible threats to social belonging. And social belonging has always been essential for human survival. For early humans, being excluded from the group could reduce access to food, protection, and cooperation. So the brain evolved to treat social signals very seriously. But here is an important reframe. Your brain is not trying to make you anxious or negative. It is trying to keep you safe. By highlighting potential problems, the brain attempts to help you avoid future harm. However, in the modern world, this survival system sometimes misfires. The brain may spend hours analyzing small social signals that pose no real danger. And once you understand how this system works, something interesting happens. You begin to recognize that many negative thoughts are simply the brain's ancient warning system running in the background. They are not always accurate reflections of reality. They are the result of a brain designed for survival in uncertain environments. By the way, if you're interested in understanding how the brain and body actually work, this channel explores the science behind those systems. Understanding human biology changes how we interpret many everyday experiences. Patterns that once felt confusing start to make sense when we look at the underlying mechanisms. And the brain's tendency to notice negative signals first is one of the clearest examples of that. It is not a flaw in human thinking. It is a survival strategy built into the architecture of the brain. Vera explains the science behind how the human system works. Subscribe if you're curious about the biology of being human.